Okay, so today is not really anything too different. It's basically all that we're doing this chapter. A lot of what we're doing this chapter up until tomorrow's lesson is doing all the things that we did in degrees and then transforming them to radians. So one of the things that we did was we found the sine, cosine, and tangent at particular degree values around our unit circle, and then we did the same thing with radians. We said, okay, well, sine of 45 degrees is root 2 over 2. But also sine of pi over 4 is also root 2 over 2. So then we looked around our unit circle, and we also found the sine of 5 pi over 3 and the cosine of 5 pi over 6 and all of those other things. The next thing that we did in terms of radians was we looked at an approximation. So we looked at the sine of 42 degrees, which just meant that we typed it into our calculator. Or we found the angle value that would produce some ratio. So that's what we're doing today, is we're just doing those things, except we're doing it in radians rather than degrees. So far we have 3 different ways that we can represent our measurements. One of the ways that we can represent our measurements is in degrees. So I can talk about sine of 30 degrees, which you should have a good idea of what that would be and what that would look like. So 30 degrees would be in quadrant 1, 30-degree reference triangle. My value here would be 1/2. We also know that this is also corresponds to pi over 6. And another way that we can represent pi over 6 is not actually in terms of pi, but in terms of radian measurement. So pi over 6 is also, if I actually type that into my calculator, 0.5236 approximately. These all would represent the same value. But however, if I actually do it on my calculator, like knowing that the sine of 30 is 0.5, I can't also say the sine of pi over 6 will end up being 0.5 because your calculator doesn't read it that way. So you want to signify to your calculator that you're in a different mode, that you're actually, this time you're talking about degrees, and this time you're talking about radians. So to do that, on mine, you go to the mode and then you go down to radian measurement, but I think in the other ones, the scientific calculator, there's like a button on the top. But we can look at that tomorrow if you can't figure it out. Just play around for a minute. Like right now it should say something like degrees in the bottom here for your scientific calculator. So you want to find, I think there's a mode button on there too that's really similar, and you want to go over to radian where it says RAD. So now I can do that same thing. I can do sine of pi over 6 and it'll also give me then 0.5. But again, if now I try the sine of 30, that's talking about 30 radians. So you have to just be careful of what mode you're in. So you have to be really cognizant of where you are. If you're dealing with degrees, if you're dealing with radians, and making sure that your calculator knows what you're trying to do. So today we're just going to be working in radians. And again, I could do the sine of, 0.5236, which is also in radians. And this is an exact answer, so it'll get something that's really close. This is really, some decimal approximation that goes on forever. This is the exact answer that's giving it, and that's some decimal. But again, we're getting something that's really close, so they should kind of be represented the same way. So for this first part, we're just going to type it into our calculator. We're evaluating the sine of pi over 6, or pi over 7. This is not a normal radian measurement on our unit circle. We only have terms of pi over 6 and pi over 3 and pi over 4 and pi over 2. Those are the only ones we know. So we'll put in pi over 7, and we get, just like we did before when we were looking at different types of ratios, we get 339? We'll round to 4 decimal places. And again, that's some ratio of some opposite over my hypotenuse or some sine value that I'm looking at. Same thing here, we're going to type in secant, which is 1 over our cosine value of pi over 9. So that's what we're going to type into our calculator, 1 divided by cosine of pi divided by 9. We get 1.0642. And cotangent, same idea. This is really 1 over tangent at pi over 5. So 1 divided by tangent of pi divided by 5. Oops. We get 1.3764 for our answers. So like that's step one, is just evaluate, type it in your calculator, make sure that when you're doing your secant or you're doing your cosecant or cotangent, you're doing 1 over that stuff evaluated, just like we did in degree mode. Like if I was asking you to find the secant of 30 degrees, you would do 1 over cosine of 30 degrees and you get 2 root 2 over, or 2 root 3 over 3, same kind of idea. And we also did this, and this was kind of on our quiz too, so we're not really like learning a ton new material today. So this is like one of the things that you can do is actually find like the radian measurement that gives that ratio, right? That's the idea, is that this is some angle. So we're solving for some angle, and in this case, radians. And we know we're dealing with radians because it tells us this. It tells us the values of S in terms of radians, so that means that when we solve for our theta value, we're going to do that in terms of radians. Now you can do this a couple different ways. You could find this angle measurement in degrees, so thinking like, okay, well I know on my unit circle that cosine is positive in quadrants 1 and quadrants 4. Since we're looking for all, that means 2 values. I know that cosine is my x value, so it'd be here 1/2, which means this is root 3 over 2, which means this is a 60-degree reference angle. And then you could figure out what that would be in terms of radians. That's totally a possibility, and that's probably the way that I would go about that. Or you can think of it like, you know, do the same thing, and then instead of thinking of 60 degrees, think about it in terms of radians. But either way, that's the idea that we're looking for, is that one of our values gives a 60-degree reference angle in quadrant 1, so that means that we're dealing with pi over 3. And we also have a 60-degree reference angle and then in quadrant 4, which, so pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So these are 2 values. When we talked about it before, like when I was finding this one, if this was 60 degrees and I was looking for quadrant 3, we did 360 minus 60. You could still do that same thing. So we could still do it in quadrant 4 by, instead of doing 360 minus our reference angle, we could do 2 pi minus our reference angle. So 2 pi minus, this is 360 degrees and this is a 60-degree reference angle, we'd end up with still 5 pi over 3. But I feel like it might be harder to do it that way rather than just like knowing your angle measurements in those different quadrants. Okay, same kind of idea for example 5. Like you might actually want to pause right now and try this one. See if you can get the angle measurements that would give this ratio of -1. So if you did, like you should be thinking, okay, where is tangent negative? So 2 quadrants, it happens in quadrants 2, and it happens in quadrants 4. And then you're thinking, where's the ratio 1, or -1 in this case? That would give a 45-degree reference angle, which means in quadrant 3 at 45 degrees, I'm dealing with like something in pi's over 4. That would be 3 pi over 4 in quadrant 3. And then in quadrant 4, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. In quadrant 4. Again, I'm doing that in terms like that's kind of how I think. I think about it in terms of some, you know, fraction. Like I know, okay, I've been doing this enough where I know all of my radian measurements in my different quadrants, but maybe that's something that you're still working on. So if you don't have it memorized, that this is, you know, 135 degrees and 315 degrees, and then coming up with those radian measurements, you might be able to like jump right to this. But either way, like this would be those angle measurements that we're looking at, and my angle measurements in terms of degrees, for example, 4 would be 60 degrees and 300 degrees. The biggest hiccup that you'll find is not actually finding these values, because we should be pretty good at that from chapter 2. It's actually finding these values. So knowing that these things convert to that, or knowing how to get to your radian measurements without actually coming up with the degree measurement in each of those quadrants too. But again, you can do it either way. You can find that that's 135 degrees and then you can convert, or know that that's 3 pi over 4, so this is 135 degrees and this is 315 degrees. Or you can just know that it's some pi over 4 angle and then kind of do that step thing that I was looking at. Like this would be pi over 4 and 2 pi over 4 and 3 pi over 4, knowing that you're in quadrant 3. So there's like several different ways. So the back part is where we don't actually have a known ratio. So this 0.96 or 968 is not like 1/2 or root 3 over 2, right? It's something that we actually know. So in order to actually do this into your calculator, or in order to actually find this measurement, we have to do this into our calculator. Okay, so if I was looking for the cosine of some angle, let's treat it like this. If I was looking at like the cosine of theta equals whatever, to solve for my theta value, I would have to take an inverse. Same idea. We're just looking for a theta value, this s value, this theta that's in terms of radians. So it won't give you something that like looks really real or looks like the right value, but it's going to be the same nevertheless. So in order to find my s, I need to take the inverse. And remember that this is in terms of radians, so it's going to look a little bit funny when we do this. We're going to get a value that's like pretty small, but again, this is just some sort of radians. And I could find out that degree measurement by multiplying by 180 over pi. So this would be 0.2537 approximately, which you don't have to do this because we're actually looking for, this is the term in radians. But I just want to show you that it's not like too crazy of an answer. This would really be 14.3 or 14.53 degrees. Okay, so like I could approximate that in a different way. But anyway, like this is not, you don't have to do this step. I just want to show you that these things are the same. So even though you're getting a value that's really small, what that corresponds to is something that's a little bit more reasonable, or something that you can wrap your head around a little bit more in degrees. Same idea if we're looking at cotangent. Remember, we have to switch to our parent function first. So if I want to switch cotangent to tangent, I would do the reciprocal. So I'm going to do the reciprocal on this side too. And then again, to solve for that angle measurement, I got to take the inverse. So that's what I'm typing into my calculator, and again, I am in terms of degrees, so the answer that I'm going to get is a little bit small, or a little, looks a little bit unreasonable, but remember this is some angle measurement in terms of radians, not in terms of degrees. Okay? Some pi value. It's just that this doesn't have pi in our answer. Okay, 2 more, and then both of these are dealing with things that are on our unit circle, which I think is like the harder part. So this one we're looking for our radian measurement that's in the interval from 3 pi over 2 to 2 pi. So if I think about where that is, remember I started here at 0, and then this over here is pi. Those are the easy ones to remember. So 90 degrees would give pi over 2, and then this would be 3 pi over 2 down here, and then back to 2 pi, since 2 pi all the way around. So I'm looking for this quadrant. So this tells me that I'm in quadrant 3. So I'm looking for secant of s is equal to 2 root 3 over 3. So if I'm looking for secant, that means that I'm really dealing with cosine. Now, if you don't remember this ratio, or how this rationalized or came from, the unit circle ratio that we know, and how this actually rationalized, you could flip it like we do normally, and then rationalize again. So I'd multiply by root 3 over root 3, and I'd get 3 root 3 on top here. And then 2 root 3 times root 3 is 3, so 2 times 3 is 6. And then that would reduce down to root 3 over 2. So here's my reference triangle here in quadrant 3, oh gosh, I said quadrant 3. It's quadrant 4. Drew it in the right one, said the wrong one. That's silly. So I'm in quadrant 4, excuse me, my bad, where my cosine value is root 3 over 2. That's dealing with the 30, 60, 90 triangle. This would then be like 1/2 or negative 1/2 if I'm in quadrant 4, not quadrant 3, quadrant 4. Then that would be then a 30-degree reference angle. And again, thinking about my degree measurements, I know 30 degrees goes along with the radian measurement of something over 6. But if you want to, you could find out what that is in terms of degrees and then look at it in terms of radians. So if I do 360 minus 30, I'd get my reference angle of 330 degrees, which then I can convert to radians, which will end up being 11 pi over 6. And that's then in quadrant 4. And for me, what I would do, so like I don't convert it to 330 degrees before I go to radians. I know that a pi over, or the 30 degrees goes along with pi over 6, and it's the last 30 degrees that I get to before I get to 2 pi. So for this one, like I think about what would 2 pi be in terms of 6, that'd be 12 pi over 6, and then it's just one less than that, 11 pi over 6. But again, that's me, I mean, I've done this, I've been doing radian measurements for 8 years or whatever since I was in your place in high school, so I know that I'm definitely like faster at this conversion than you, which is totally fine. I should be, but that's what my process. I just want to explain a little bit of my process of what goes on in my head to get to that point. But if this works for you, converting to 330 degrees and then finding the radian measurement because you've memorized them or you know them from there, or you convert them, or whatever it is that you do to get to your answer, that's fine. Like I don't care how you get to this answer, I just want you to be able to get there. Okay, last one, a little bit more challenging. We're looking for the tangent of root 3 over 3. So this one's a little challenging because we don't normally deal with this one. This is still on our unit circle. So what that actually did come from was a rationalization of 1 over root 3, which means that came from our sine and cosine of 1 over 2 and then root 3 over 2. So that's what we're thinking about as we're going through that. Hopefully we've seen this enough and know that it converts or rationalizes to root 3 over 2, and then knowing that it comes from like what this would be. So I know tangent is positive in quadrants 1 and quadrants 3. And again, knowing like how this actually came to be was 1 over root 3, so I know that this side needs to be 1/2. And negative 1/2, and then root 3 over 2 on my other ones, which means that I can come up with then this reference angle of 30 degrees. Okay, so if this is a 30-degree reference angle, that means that my two answers would be 30 degrees and 180 plus 30, which would be 210. Again, I'm finding these measurements first, you don't necessarily have to. This corresponds to pi over 6, and then my other angle measurement that I have would be this. So this is pi, and then one more pi over 6 would be 7 pi over 6. 6 pi over 6 gives pi, and one more is 7 pi over 6. Or you can convert it either way. So those are my two answers. And this one we're looking for all of them in this quadrant, so making sure that you get 2. And I'm sorry, I meant to say this earlier. Totally forgot that I changed this. I had the wrong measurements first. First I had it in terms of degrees, but I want you to do it in terms of radians. So we're looking for from 0 to 2 pi. So again, it's not nothing new really. You're just like coming up with the angle measurements in degrees. But we came up with angle measurements in degrees before that would give these ratios, and now we're just doing radians.